Okay, so we want to find equations of both tangent lines at the point. Here's a little sketch of the cycloid to the right here. And we can see I've written in red, um, the tangent line. So like here's one tangent line, and then here's another tangent line. And this is all at this point, 0, 2. And of course, to find the equation of both tangent lines, we need to know the equation of a line. So I've written that down here at the bottom. And our point is going to be 0, 2. And our slope is going to be dy dx evaluated at that point 0, 2. So that's what we want to know, is what is the slope of this tangent line? What's the slope of this other tangent line? Okay, now we've got the formula for dy dx. The formula for dy dx is going to be dy dt divided by dx dt. And this is, of course, assuming that dx dt is not equal to 0. Which here, dx dt is not equal to 0 because just from looking at the picture, our tangent lines aren't vertical. Okay, so let's go ahead and compute dy dt and dx dt, and then we'll be able to combine them for our dy dx. Okay, so what is dy dt? Now here's y. Y is 2 minus pi cosine t. So dy dt should be, let's see here, dy dt should be minus pi times the derivative of cosine t, which will be negative sine t. So we should end up with pi sine t. Now, what about dx dt? For dx dt, we should have, which is here, so we should have 2 minus pi cosine t. Okay, so 2 minus pi cosine t. And now putting it all together, we'll have pi sine t divided by 2 minus pi cosine t. Now here's the problem. We need to figure out what is this derivative at the point 0, 2. In order to do that, we need to find out what is the value of t when we are at this point. So the idea is that we cross through the point twice. So we start off, perhaps I should use a different. Okay, so we're starting off going here. This is the direction of the particle. Bam, it crosses through the point 0, 2. There is a tangent line right now, and that tangent line has a slope, okay? And now it keeps going, the particle keeps traveling, and it passes through again. And so now we've got our second dy dx. Okay, so that's kind of the idea. So we've got to figure out at what times is our particle passing through that point 0, 2. And in order to do that, we need to go, basically we're going to look over here. We need to figure out when is x equal to 0 and y equals 2, right? So when, for what value of t, for which t is x equal to 0 and y equal to 2. Okay, now when is x equal to 0? Remember, x is 2 pi minus sine t. So we need to know when is 2 pi minus sine t equal to 0. And similarly, we need to know when is 2 minus pi cosine t equal to 2. So this means we are solving a system of equations. 2t minus pi sine t equals 0, and 2 minus pi cosine t needs to equal to 2. This bottom equation here can be simplified to cosine of t equals 0, right? Because if we have 2 minus pi cosine t equals 2, then we can subtract 2 from both sides. So we have minus pi cosine t equals 0. We can divide both sides by minus pi, and we just get cosine t equals 0. Okay? And now the first equation simplifies to, we could say 2t equals pi sine t. Okay, so we could rewrite this system as 2t equals pi sine t and cosine of t equals 0. So now when is cosine of t equal to 0? Well, if we think about the cosine function, it starts at 1, goes down, right? So cosine of t is equal to 0 infinitely many times. Pi over 2, 3 pi over 2, 5 pi over 2, right? So we could say t equals pi over 2, 3 pi over 2, 5 pi over 2, etc. And there's nothing special about the positive values of t. We can also have negative values, so we can put in plus or minus, plus or minus, plus or minus. Now we've got to figure out for what values of t do we have 2t equal to pi sine t and t is equal to plus or minus pi over 2, plus or minus 3 pi over 2, plus or minus 5 pi over 2, etc. Now, looking here, we can automatically eliminate the, let's see here, what is sine? Sine of pi over 2. Okay, so what is sine? Sine starts here, so it's going to be 1 or negative 1, right? So sine of pi over 2 is going to be 1 or negative 1. So let's see here. So sine of pi over 2, 3 pi over 2, 5 pi over 2, negative pi over 2, negative 3 pi over 2, right? Sine of anything that looks like 2k plus 1 over 2 times pi. This is always going to be plus 1 or minus 1. So 2t equals pi sine t, and these values of t are satisfied, means we're looking at plus or minus pi is supposed to equal to 2t, which means t must be plus or minus pi over 2. Okay, so another way to think about this would be to say, if you take any of these larger values of t, when you plug them into the left-hand side, 2 times t is going to be bigger than pi, right? Because sine of t is always going to be in between 1 and negative 1. So we figured out when our particle is passing through the point, it occurs at t equals plus and minus 2. Sorry, pi over 2. At the page below. Okay, so for at t equals pi over 2 and at t equals negative pi over 2, our particle is passing through. So x of t comma y of t is equal to 0 comma 2. X of t comma y of t is equal to 0 comma 2. Okay, and our dy dx, which we said is equal to, let's see here, it's supposed to be, copy, this pi over pi sine t over 2 minus pi cosine t. So this will be pi times sine of pi over 2 over 2 minus pi cosine pi over 2. Okay, and what is sine of pi over 2? That will be 1. It'll be pi times 1. And what is cosine pi over 2? Cosine of pi over 2 is 0. Should be 2 minus 0. So this will just be equal to pi over 2. Now let's see what happens over here at the time when t equals negative pi over 2. So our slope of the tangent line is going to be equal to pi times sine of negative pi over 2 divided by 2 minus pi times cosine of negative pi over 2. So we should get negative pi over 2 minus 0, which is just negative pi over 2. Okay, so now we've got our slopes. So this is m, right? M is going to be plus or minus pi over 2. And our point x naught, y naught, 0 comma 2 for both. So our equation of the tangent line is going to be y minus 2 equals pi over 2 times x minus 0, which is the same as y equals 2 plus pi over 2x. Then over here we'll have y minus 2 equals minus pi over 2 times x minus 0, which we can rewrite as y equals 2 minus pi over 2x. Okay. And so I just wanted to show you kind of what we can look it up on Desmos. And the point that we're interested in is at 0, 2. And we could plug in y equals, let's see here, equals, what was our first equation? 2 plus pi x over 2 divided by 2. And that's looking pretty, isn't that looking pretty tangent? It'd be very useful to use this to approximate the value. That's so close we can barely tell the difference, right? So the red and blue makes purple, and this tangent line is literally purple. And now let's do y equals 2 minus pi x over 2. And there we go. So we've got our tangent lines, and they are very close, very good approximations to our parametric curve at this point.